In this question, we're provided again with two solids. We've got images showing their structure. Both are molecular solids in which the molecules contain non-polar covalent bonds. So solid X and Y are both molecular solids. So the type of interparticle force holding them together for both of these is dispersion forces, since we have non-polar molecules. And dispersion forces, those are the weakest type of force that we have. Now let's compare solid X and Y. We know they're the same types of molecules, the same types of forces between them. But if you look at solid X, you'll notice that the molecules are bigger. They're 5 long versus just 3 long in terms of that central atom. So they have different sizes of molecules. So if we think about dispersion forces, we already discussed dispersion forces are when the electron cloud or the electrons in their orbits around their atoms move around a bit, and sometimes they all happen to gather on one side, sometimes they're more spread out. So at particular moments, electrons may be more heavily on one side of a molecule than the other, resulting in a temporary polar molecule or a temporary dipole. So for example, for solid X, if all the electrons happen to be over this side for a moment, we get a temporary negative dipole at this end and a temporary positive dipole at this end. So because solid X has bigger molecules than solid Y, they've got bigger electron clouds, and so there are more possible different fluctuations that it could have, and therefore stronger dispersion forces between the molecules. So solid X has slightly stronger interparticle forces, and the reason why is that its molecules are bigger and so have bigger electron clouds, which is number 3 from this list.